So here is your question number 24. So it is mentioned, draw a ray diagram for formation of image by a Cassegrain telescope. Okay. So Cassegrain telescope, its other name is what? Reflecting type telescope. So the diagram is like this. I am going to draw actually. Okay, so all of you see it properly and practice it properly actually. So here another mirror is there. Yes. So this mirror is called objective mirror. Another mirror is called secondary mirror. Okay. So in this case, parallel rays are coming from distant object, and after reflection it falls upon the secondary mirror. Yes, and here is our eyepiece. This person is eyepiece. Then from reflection from secondary mirror, the reflected rays enter into the eyepiece. Okay, so we have to mention here parallel rays from distant object. Okay, yes. So this telescope is called a reflecting type telescope, or it is called Cassegrain telescope. Okay, I hope it is clear to all of you. And again it is mentioned why these telescopes are preferred over refracting type telescopes. Write any 2 points. That means you have to write the advantages of this type of telescope, reflecting type telescope. So for second bit, you have to write the answer like in this way. So in case of objective mirror, if you will see objective mirror, in case of objective mirror, it is free from spherical and chromatic aberration. So objective mirror is free from spherical and chromatic aberration. Chromatic aberration means color related problem. This is your color related problem. Okay, if another advantage, objective mirror is having large aperture. It is having large aperture. So what is the advantages? So that it can collect more light, which implies because of this image is brighter. Okay, objective mirror having large aperture, it collects more amount of light rays, so that image is brighter. Okay, so these are the advantages of this type of telescope. Next thing is, another question is available in this question number, that is for VI candidates. It is mentioned a Cassegrain telescope is built with an arrangement of 2 mirrors placing them 20 mm apart. So 2 mirrors placing them 20 mm apart. That means you have to draw the diagram. So that we can understand the question properly. Okay, this is one mirror, this is another mirror. One is objective, another one is secondary. So this is our telescope. Okay, and they are placed 20 mm apart. That means the distance of separation between these two mirrors is 20 mm. It is given. And if the radius of curvature of large mirror is 200 mm, radius of curvature of large mirror, and for large mirror remember its radius of curvature is given 200 millimeter and small mirror radius of curvature is 150 millimeter. Where will be the final image of an object at infinity be? So for objective mirror, object is at infinity. So now for objective mirror you can see, for objective mirror object is at infinity. So if I will write for objective mirror, U is, this is our objective mirror, suppose, think. So U is at infinity and it is a part of this imaginary sphere. So this is the pole, this is its center of curvature, and pole to center of curvature, this distance is radius of curvature. But for objective mirror, incident rays are coming from infinity to mirror. This is the direction of incident ray. Okay, so here radius of curvature is negative or positive. It is opposite to direction of incident ray. Pole to center of curvature, opposite to direction of incident ray. So radius of curvature will be negative. So U is given minus infinity and radius of curvature is minus 200 millimeter. So what will be the focal length of objective mirror? R by 2, that is your minus 100 millimeter. So we can now see what is the image distance in case of objective mirror. Thus, from these two data, we can calculate image distance in case of objective mirror is, we have to use mirror formula, 1 by V plus 1 by U is equals to 1 by F. Okay, so 1 by V plus 1 by minus infinity is equal to 1 by minus 100. So it is 0. So V is how much? Minus 100 millimeter. V is minus 100 millimeter. So that means as per the diagram, so after the reflection, image will form. After this reflection, if I will consider this is our incident ray, these are the incident ray. So after reflection, you see the image will form at this point. Okay, this is the ideas. So as per the calculated value, V is minus 100 millimeter. So in magnitude we can think, if this is our mirror, yes, so this distance is, we can say this is our 100 millimeter image distance. So now see one thing, this is the objective mirror and here another thing is, this is the secondary mirror and this one is secondary mirror. So the distance of separation between them is 20 millimeter and due to reflection the image is formed at a distance of 100 millimeter. So this is your ideas and this total distance is 100 millimeter. So from for secondary mirror, so what is the object distance for secondary mirror? Now we can see the object distance is 100 minus 20, that is 80 millimeter. But we have to think whether it is positive or negative as per sign convention. So this is the direction of incident ray for secondary mirror. So this is your secondary mirror. This is secondary mirror. For secondary mirror, this part is pole. Yes, and pole to object, this distance is object distance. Its magnitude is 80. But what is its sign? So now I dash behaves as virtual object for secondary mirror. So it is measured along the direction of incident ray. Okay, see it properly. This is the direction of incident ray, pole to I dash along the direction of incident ray. So it is positive. So here we can write one thing. Another thing, its radius of curvature is 150 millimeter. Radius of curvature means it is a part of this imaginary sphere. And its pole to center of curvature. Again, we can draw another picture for this. So this is our, let's think this is our secondary mirror. this is our secondary mirror, and in case of this secondary mirror, this mirror is a part of this imaginary sphere, and here is our center of curvature, and it's the pole. This is the direction of incident ray for secondary mirror, and pole to center of curvature, this is along the direction of incident ray. Yes. So radius of curvature is plus 150 millimeter. Yes, so we can see, or we can think now, and this is the location of I dash. Suppose this is I dash, so this distance is how much? 80 millimeter. Yes, so now we can write I dash behaves as virtual object for secondary mirror. Okay, now in case of secondary mirror, this secondary mirror, U is our plus 80 millimeter, and radius of curvature is plus 150 millimeter. That means focal length is r by 2, it is plus 75 millimeter. So now we can calculate the final image distance. Okay, so thus as per mirror formula, 1 by v plus 1 by u 1 by f. So 1 by v is equals to 1 by f minus 1 by u. So 1 by 75 minus 1 by 80. So it will be 75 into 80. So 80 minus 75, 5 by 75 into 80. So this is 1 by 1200. So 1 by v is 1 by 1200. So v is equals to 1200 millimeter. Okay. So as per the given data, I hope it is clear. Where will be the final image of an object at infinity v? Okay, this is our answer. So now we can take the screenshot and solve in this way. Okay, thank you, have a nice day.